The breakdown of glucose releases a lot of energy, but just how much energy? If I were to drive my Honda Civic to have equivalent kinetic energy to the energy released from this reaction, I would have to drive at 270 kilometers an hour. I would get a speeding ticket. Recap. Adenosine triphosphate is a molecule used for chemical energy. The phosphate groups get broken off, and that releases the energy that was stored in the bonds. When sugars break down, the energy is stored in the form of ATP. That ATP goes all through the body and does important things, but only 30% of the energy goes into the formation of ATP. The rest is released in heat, but just not all at once. So if the combustion of glucose would just happen all at once in our bodies, how would that affect our body temperature? I will explain with science. A chemical reaction will either take in energy or release energy. This change in energy is called the enthalpy, symbol delta H. If we assume pressure and volume will remain constant, enthalpy is equal to heat. Cellular respiration is exothermic, meaning it gives off heat. The system is losing energy. That's why the delta H value is negative. Take a look at the units. Kilojoules per mole. What does that mean? In this case, the delta H value is based on glucose. So for every mole of glucose reacted, 2,880 kilojoules of energy is released. That's a lot. It's about time I throw an equation at you, so here we go. Q equals mc delta T. What up? Where Q is heat, m is mass, delta T is change in temperature. Anytime there's a delta, it means it's a change or a difference. And C is specific heat capacity, which is the energy required to raise the temperature of 1 gram of substance 1 degree Celsius. It's different for everything. How does this relate to enthalpy? Enthalpy is equal to the absolute value of the gain or the loss of the heat of the surroundings. Did that make any sense? Bear with me, I'm getting back to biology in the next jump cut. The human body, on average, is made up of 70% water. The average human mass is 70 kilograms. Weird. So, the average human has 49 kilograms of water inside of them. An experiment you can do to measure the heat released from a reaction is using water as the surrounding. The energy can be calculated by the change in temperature of the water. Say I ate this entire package of nerds. Through the magic of stoichiometry, I know that if all the sugar reacted, it would release 696 kilojoules of energy. There's a link to the full solution in the not sidebar. Now let's see what 700,000 joules would do to the average person's internal body temperature. I can only show you theoretically because otherwise it would be unethical. And to keep it simple, I'm only going to consider the change in temperature of the water. We know all the variables except for T, so we isolate and solve. And we get 3.3 degrees Celsius. That doesn't sound like a lot because that's the change in temperature. The average body temperature is 37 degrees Celsius. An internal body temperature of 40.3 degrees Celsius is considered hyperpyrexia. In other words, a high-grade fever requiring immediate medical attention. Ouch, dude. So if all the sugars in this box of nerds were to combust inside your body, you could die. I'm happy cellular respiration happens in steps. It may make biology class a bit more boring, but at least I can enjoy my box of nerds without dying. This has been another installment of Remi-Rix the Science Chick Extra Credit. I'm your host, Remi-Rix the Science Chick, saying go forth and eat nerds. I mean, go forth and do science. Click on the left annotation if you want to watch the episode of Remi-Rix the Science Chick about photosynthesis and cellular respiration. Or click on the right annotation if you want to hear about the time that I got a 2nd-degree burn because I made a calculation error in the lab. It sucked.